A crowd starts moving toward a single narrow exit, and within seconds, nobody is thinking clearly anymore. Not because they're bad people, not because they're weak-minded. Something takes over that has almost nothing to do with individual judgment, and almost everything to do with what happens when many bodies try to move through one small space at the same time. Here's the strange part. Engineers who study structural failures, the same investigators called in after grain silos collapse under the weight and pressure of their contents, have found something remarkable when they turn their formulas toward crowds instead of grain. The math describing how tightly packed particles behave under pressure describes human crowd crushes with unsettling accuracy, and it might explain why panic spreads through a group of people almost like a physical force rather than an emotional one. Sound familiar? It should, if you've ever felt the particular helplessness of being swept along in a crowd, your own feet no longer fully your own, moving because the people around you are moving, not because you decided to. For years, researchers who study crowd disasters have applied engineering principles borrowed directly from the study of granular materials, sand, grain, gravel, anything made of countless small particles under pressure, to understand how deadly crowd crushes actually happen. What they found is unsettling. Beyond a certain density, a crowd stops behaving like a collection of individual people, making individual choices, and starts behaving like a fluid or a solid under mechanical stress, following the same physical laws that describe grain shifting inside a silo moments before it buckles. Here's the mechanism worth understanding. Researchers who study grain silo failures have long known that stored grain doesn't just sit passively under its own weight. As pressure builds, grain particles can form temporary arches and bridges that hold enormous stress in place, sometimes for long stretches, until the structure shifts slightly and the whole arrangement suddenly gives way all at once, releasing tons of accumulated force in a matter of seconds. It's not a gradual event. It's calm, then catastrophic, with almost no warning in between. Applying this same model to crowds reveals something disturbing. In a densely packed crowd, people don't just get pushed by whoever's directly next to them. Force travels through the crowd the same way it travels through grain under pressure, transmitted from body to body across distances far beyond what any individual person can see or control. A push at the back of a crowd can arrive, amplified and unpredictable, dozens of rows away, exerting force on someone who never even saw where it started. Which means the person who ends up crushed against a wall or a barrier may have done nothing wrong at all, made no bad decision, panicked at no point, simply stood in the spot where the accumulated force of hundreds of other people finally had to go. This is where it gets stranger. A separate line of research, this time studying the specific density at which crowd crushes become likely, found a strikingly precise threshold, roughly the same density at which those grain arch structures inside silos start to become unstable. Below that density, people can generally still move independently, adjust their own footing, breathe normally. Above it, individual movement becomes physically impossible. Chest compression can occur even while people remain standing upright, and no amount of individual awareness, calm thinking, or personal control can prevent what happens next, because the physics of the situation has already taken over from the psychology of the people inside it, which reframes panic itself. The common assumption is that people panic first and the crush follows. But in many documented crowd disasters, investigators have found the opposite sequence. The physical crush begins first, silently, as density crosses that critical threshold, and the panic that follows is a response to bodies suddenly losing the ability to move or breathe normally, not the cause of it. Fear, in these situations, is often the mind's accurate recognition that something has already gone catastrophically, physically wrong, not an overreaction that makes things worse. Here's the part that should genuinely reframe how you think about crowd behavior. If crowd crushes behave according to the same equations governing grain silos, then the popular idea of mass panic, a phrase that implies individual people losing rational control and making the situation worse through fear, may be describing an effect rather than a cause. The people caught in these disasters weren't primarily failing psychologically. They were caught inside a physical system that had already crossed a threshold no individual choice could reverse. The same way a single grain particle inside a silo has no meaningful agency once the surrounding pressure decides where the whole mass is going to move. This also explains something curious about crowd safety design. The most effective interventions engineers have identified aren't focused on training people to stay calm, a psychological fix aimed at individuals. They're focused on density control, wider exits, staggered entry points, barriers that prevent a crowd from ever reaching the critical threshold in the first place. Engineering solutions aimed at the physical system, not the minds inside it. Let's go a layer deeper. Researchers who study both granular materials and crowd dynamics have found that the exact same jamming and unjamming patterns appear in wildly different systems. Sand pouring through a narrow funnel, molecules moving through a chemical bottleneck, even data packets competing for bandwidth in a crowded network. Whenever many discrete units try to move through a single limited passage at once, the same mathematical signature shows up: sudden clogs, temporary stable arches, then abrupt, catastrophic release. It doesn't matter whether the units are grains of sand or human beings. Above a certain density, moving through a narrow space, they all start obeying the same underlying physics, which raises an unsettling, clarifying thought. Some of what feels like the deepest, most human moments of collective terror, the crush of a crowd, the helpless shuffle toward an exit that isn't opening fast enough, may have less to do with human psychology than with an extremely general property of matter itself. Any sufficiently dense collection of discrete objects, moving toward a bottleneck, will eventually behave the same way, whether those objects have minds or not. Think about the last time you were in a packed space, a subway platform, a concert exit, a crowded doorway, and felt that particular wordless tension the moment things got just slightly too tight. That tension might not have been a rational fear. It might have been your body, quietly and correctly, sensing the earliest edge of a density threshold that has nothing to do with confidence or composure, and everything to do with physics that doesn't care how calm you are. And maybe that's the real answer to why panic spreads through a crowd the way it does. It was never really about people losing their minds together. It was about bodies obeying the exact same equations that govern grain inside a silo, arching, holding, and then releasing all at once, the moment the pressure finally has nowhere left to go.